everyone. Hope you're all having a wonderful day. Let me introduce myself. I am B.M. Naagaarjun, working as a faculty at HIMT. Today, in this module, we are going to look at the safety parameter settings in ECDIS. Let's have a look at the learning objectives. In this module, we will look at the phasing out of paper charts, ECDIS as a replacement for paper charts, how ECDIS is used as an anti-grounding tool, what is a safety frame, what are the safety parameters, what is the meaning of the term contour, what is a shallow contour, what is a safety contour, what is a safety depth, and what is a deep contour. I'll be showing you the demonstration for each of these 4 safety parameters. The demonstrations are shown on Transas ECDIS, but it would be the same on all manufacturers. The next one, we'll be looking at how ECDIS chooses the contours, the safety parameters calculation and the formulae used, and finally, we'll conclude it with a recap. In the recent development, the UKHO has decided to withdraw paper chart production by 2026. This is in the news dated 27 July 2022. The paper charts have served the seafarers for over 200 years as the primary means of navigation. So as per this news, soon we will not have any more paper charts for navigation. But we might still have non-navigational paper charts like routing charts, anti-piracy charts, or mariners routing guides, etc. But the paper charts used for navigation purposes, they are being stopped from printing from the year 2026. This is also, on the lighter note, a cause of concern for the dev team. In which way? Yes, we guessed it right. Paper charts have also been used for the source of stenciling for many decades now. So when there won't be any more paper charts from 2026, we'll have to look at different sources for stenciling. The reason for withdrawal of paper charts. The UK Hydrographic Office announced its intention to develop options for the withdrawal from global paper chart production by late 2026 to increase focus on its digital navigation products and services. Peter Sparks, the chief executive of the UKHO, said, and I quote, "The decision to commence the process of withdrawing from paper chart production will allow us to increase our focus on advanced digital services that meet the needs of today's seafarers." ECDIS as the replacement for paper charts. The move to digital navigation solutions has been accompanied by a rapid decline in demand for paper charts, driven by the SOLAS mandated transition to ECDIS and the wider benefits of digital solutions, including the next generation of navigation services. So from the above statement, it's pretty clear that the introduction of ECDIS has been the reason behind the phasing out of paper charts, where the seafaring community is moving forward with the technology. ECDIS was introduced as an anti-grounding tool to enhance the safety of navigation. After the introduction and implementation of ECDIS, the number of groundings has seen a sharp decline, by about 30%. ECDIS serves its anti-grounding purpose by the way of setting a safety frame and various alarms. First, let's have a look at safety frame. A safety frame is a marginal boundary around own vessel in the form of a box. Here, this is the ship's symbol and this is the heading line of the ship. That means the direction in which the ship is moving. Here we can see a red color square box around the ship's symbol. This is called as the safety frame. This shape or the size of this frame is alterable. That means we can change the size or shape of this frame. We can set our own parameters. When the edge of this frame, when the edge of this red box touches any danger, be it a navigation aids or be it a wreck or be it a land danger or safety counter, any kind of danger, an alarm will be activated. Okay, now let's have a look at how to set this safety frame. Please come down here. Here you have the safety frame setting. That means basically we are going to set the shape of this box. So they will be set in length and width. It's just like a rectangle. Now we are going to set the length of the rectangle. That means in the direction in which the ships move, in the direction of its heading line, that will be the ahead setting. And the width of the box will be from the center of the ship on the port side and on the starboard side. So port and starboard. Now here we have to notice that the port and starboard side, the width will be set here in nautical miles, that is in distances. You can click here and you can set whatever width you want to set in here on port and starboard side. You can see the shape or the size of the box is changing now. Okay. One thing we have to notice with the ahead is it is not set in distance but in minutes. That means the safety frame is a speed variable factor. So it is set in time rather than distance. Why? Because if your ship is going to make 12 knot speed and if you want a 15 minutes of look ahead frame, a safety frame, you are going to set a distance of 3 nautical miles if the ahead will be in distance. Let's say you are increasing the speed and the same ship is now making 20 knots. Now, if you still want a 15 minutes look ahead distance, then the distance will have to be set for 5 miles. That means basically from 3 you will have to increase it to 5. So that means during a voyage you will have to constantly alter the ahead direction of the safety frame if it will be set in distance. To avoid this, the ahead direction or the length of this safety frame will be set in minutes, so that with respect to whatever speed you're making or you're changing, the length of this box will change. For instance, let's see. Now we are making 1 knot speed, so it almost looks like a square in the form of a box. I'll just try to increase the speed of the ship from the telegraph. Now we will see what happens to the shape of this safety frame. As the ship is picking up speed, please pay attention to the shape of the safety frame, this red color box. It was initially in the form of a square. You can see now it is increasing in its length. The square has become a rectangle now. In which direction? In the direction in which it is moving. Whereas the side, that means the width on port and starboard side of the ship, is not changing because it is set in distance, which is in nautical miles, and it is constant. So the width of the safety frame is constant because they are set in distance, whereas the ahead direction, which is the length of the rectangle, it is variable as per the speed. Initially we were making 1 knot. At that time it looked like a square box. Now the speed is increasing to 6 knots. The ship is in here. So this is a look ahead distance, the length of the safety frame box. So in 15 minutes the vessel would be in here at the edge of this box. That is the idea. 15 minutes from now the vessel would be in here. So we are getting an alarm about a danger 15 minutes in advance. So it makes a lot of sense when the length of this box changes with the speed of the vessel. Okay, now from a box it has become a rectangle. Now it also works vice versa. Let's see what happens when I reduce the speed. I started reducing the speed. Now soon you will be able to see that this rectangle will again start to decrease in its shape, size, and becomes a square, or proportionately the size will get decreased. So it's important to remember this one. The head will be set in time, the minutes of the time, whereas the port and starboard will be set in distance, which is a nautical mile. Port and starboard represents the width of the box or this rectangle, so they are constant, and the ahead one represents the length of the rectangle, which is a speed variable factor, so it makes sense to keep it in minutes of the time. So this safety frame forms the crust for your alarm systems, because whenever the edge of the safety frame touches any danger, at that time you are going to get any alarm. It's going to alert the user. So it's very important to know the setting of the safety frame. Please refer to your company SMS as to what ahead time and what port and starboard parameters are required for setting up the safety frame on your ECDIS. Also, this size of the safety frame will be variable if you check your SMS. Out at sea and when during coastal and when during confined passages, you might have to alter these parameters in order to reduce the number of alarms. Again, please check your company SMS. Now you can see the length of this box is decreasing. Now we can clearly see the length of the box has reduced. Now it has almost became a square. Alarms. An ECDIS is only as good as its alarm settings. When its alarm settings are incorrect or insufficient, it does not serve its purpose as an anti-grounding tool. One of the important alarm settings is the safety parameters. Safety parameters primarily consists of 4 elements as below. They are shallow contour, safety contour, safety depth, and deep contour. Please note, out of these 4 safety parameters, 3 of them, that is number 1, number 2, and number 4 are contours, depth contours, whereas number 3 is a depth. The calculation and the formula part of it, we'll have a look at it later. But for now, it's better to learn these parameters in this particular order for the ease of use. Let's first have a look at what is the meaning of the term contour. A depth contour is a line joining the same or similar depths. In this particular diagram, what we are saying, we have 2 depth contour lines. One is a 15-meter contour and the other one is a 20-meter depth contour line. On one side of the 15-meter depth contour line, the depths are shallower or less than 15 meters. Whereas on the other side, they are all greater than 15 meters. The same applies for the 20-meter depth contour line. On the shallower side of the 20-meter depth contour line, the depths are lesser than 20 meters, whereas on the deeper side, they are more than 20 meters. So the area between the 15-meter contour line and the 20-meter contour line will have depths in the range of more than 15 meters and less than 20 meters. We'll have a look at the first parameter, which is the shallow contour. On this particular ENC, we have various contours here. This one is a 5-meter contour. This one is a 10-meter contour. This one is a 20-meter contour. And this one here is a
30-meter contour. And this is a place where you set your shallow contour settings, shallow contour and deep contour settings. Shallow contour at this instance is set to 10 meters. That means the 10-meter contour is chosen as a shallow contour. So what is a shallow contour here? Let's first understand what is a shallow contour. Shallow contour is going to indicate you which will be the first point of contact with the ground. That means basically it indicates your grounding depths. Okay, we will have a look at the formula part later. So this is the line. When you cross this line, the depths are shallower where your vessel is going to touch the bottom. So we would never want to cross this contour line. So for visual indications, the area shallower than this shallow contour would be painted in dark blue in color. It is following a less than principle. Please remember, less than principle means when I choose the shallow contour to be 10 meters, the 10-meter contour is selected and all the depths shallower than this is painted in dark blue color. You can see there is also a 5-meter contour in, but that is also included because everything less than this 10-meter contour would be painted in dark blue in color.
But if the ECDIS generates alarm when the safety frame touches the shallow contour, it will be too late or the grounding is almost imminent. So for this purpose, we need a safety margin where an alarm will be activated well in advance before the vessel touches the bottom. This is where the next safety parameter called safety contour comes into place. Please remember the hint. The term safety, which is common for both safety margin and safety contour. So safety contour is nothing but a safety margin.
Now we are going to have a look at the second parameter, which is safety contour. Safety contour is basically a safety margin before actual grounding. We already saw that our vessel will touch the bottom when it crosses the shallow contour. So in order to avoid that, we need to have a safety margin that is provided by the safety contour. Since we are talking about the only safety margin available before the vessel grounds is the safety contour, this is the only one out of the 4 parameters to activate an alarm in here when the edge of the safety frame touches this safety contour. This safety contour has a unique feature. Please see that this is the only contour which is represented by a bold thick line, whereas other contours does not have a bold line. And this also works on a less than principle. That means when I set safety contour setting to 20 meters, it shows the 20-meter contour and all the depths shallower than 20 meters are going to be painted in light blue color. So the safety contour is basically a demarcation between non-navigable waters and navigable waters. That means on the shallower side of the safety contour are, which is the light blue and dark blue colors, are non-navigable waters, and on the deeper side of the safety contour is the navigable area for the vessel. So basically we would never want to cross the safety contour. Hence, there is a hint. Please remember, when you're setting safety contour, it cannot be less than the shallow contour. Now let's have a look at a demonstration of how the safety frame generates an alarm when its edge touches the safety contour. Now the safety frame is smaller in magnitude, which is in the form of a red square. I've increased the speed of the ship. So as soon as the safety frame, we know that safety frame grows with the speed of the ship. So when the length increases and when its edge makes contact with the safety contour for the first time, we can see there will be a new alarm in here. We'll wait for it. We can see the safety frame is increasing in its length in the direction of the ship's heading. Please keep monitoring here. Now it has given us a nav danger alarm. The safety frame edge has not touched the safety contour yet. Now it's about to touch. Okay. Now after it has crossed it, it has given you a safety contour alarm. Before proceeding to deep contour, let's see what happens when you need a certain contour when it's not available on the ECDIS. What does ECDIS do? For instance, now I chosen my shallow contour to 5 meters. This is the 5 meter shallow contour line marked with dark blue color. And safety contour I selected to 20 meters. This is a 20 meter safety contour line marked in bold line as we saw. And this is a 10 meter contour. So basically we have 5, 10 and 20, only 3 contour lines available in here. What happens if I need a 7 meter shallow contour line? Whereas only 5 and 10 are available, 7 is somewhere in between, but there is no contour line. When I change this shallow contour to 7 meters, the ECDIS automatically chooses the next higher available contour line, which is 10 meter as the shallow contour. This is how it works for any contour: shallow contour, safety contour and deep contour. Whenever you're trying to select a contour line which is not available on the ECDIS for that particular ENC, the ECDIS automatically chooses the next higher, not lower, next higher available contour line for that particular setting. Let us also see what happens when both the shallow contour and safety contour had to choose the same value. For instance, shallow contour is 7 meters, but there is no 7 meter contour. It took the assume the 10 meter contour. Let's see. And the next available after 10 meter contour is the 20 meter contour. Let's see what happens when I set the shallow contour to a value of 11 meter. We can see that there is no 11 meter contour. After 10, the next one is 20 meter contour, which is already taken by the safety contour. When I select shallow contour to 11 meter now, both shallow and safety contour will have to share the 20 meter contour between them, because that is the only next available contour after the 10 meter contour. In this case, the 20 meter contour line will be bold in feature, and the depth wise it will assume the dark blue color which is from shallow contour. That means a 20 meter contour is split or shared between both shallow contour and safety contour. Safety contour gives the bold line and the shallow contour gives the dark blue color. This is how it works. Now let's take a look at the third parameter, which is deep contour. Deep contour represents navigable waters. Here you can see I set deep contour to 20 meters. So the area which is 20 meter is same as the safety contour. Deep contour works on a more than principle. Please remember, so far we saw shallow contour and safety contour which works with a less than principle. That means the contour and the waters shallower than them will be painted in their respective colors. Whereas deep contour is going to work in a more than principle. That means I chose the same deep contour as the same one as the safety contour, which is 20 and 20. This is a 20 meter contour line. The areas deeper than 20 meters, that is more than 20 meters, are going to be painted in white color, marking the navigable waters. So it will give a hint to us that the deep water contour value cannot be less than the safety contour value. Okay, now let's see. We have seen 3 colors so far. The shallow contour, dark blue color, less than principle. That means all the depths less than shallow contour depth, which is 10 meters, is going to be dark blue. Next is safety contour, which is again less than principal. We chose 20 meters as safety contour. So 20-meter contour selected, and the depths less than 20 meters and more than 10 meters are painted in light blue color. The third one is deep contour, which we chose the same as the safety contour 20 meter, but now it works on the more than principle. That is, the depths deeper than 20 meters are marked in white in color, marking the safe waters for navigation. Now let's see how deep contour can be used to advantage. For instance, let's take MARPOL Annex 2 tank washings discharge criteria, which requires chemical tankers to be in a depths deeper than 25 meters. On a traditional paper chart, this would require constant fixing of ship's position to make sure that the ship stays in depths greater than 25 meters. Whereas on ECDIS, we can make use of this deep contour to create a clear area for this operational requirement. Please remember, this has nothing to do with the safety of navigation itself, as there is no danger of grounding. Let's see how to do this. Our present safety parameter settings are: the safety contour is 20 meters and a deep contour is also 20 meters. We know that safety contour works on a less than principle, whereas deep contour, even though has the same value as a safety contour, works on a more than principle. So this is a 20-meter contour line chosen as a safety contour, so it is a bold feature. So the depths shallower than this line are light blue in color, safety contour, and the depths deeper than this are white in color, deep contour. Now, on a chemical tanker which intends to discharge its tank washings into the sea, we just need to create a clear area for this operational requirement. As I mentioned earlier, what we do, we just go to this deep contour and enter the required depth, which is 25 meters, and we are going to take advantage of its more than principle. When I select this, the ECDIS automatically selected the 30-meter contour as the deep water contour, because there is no 25-meter contour, and we saw earlier how ECDIS chooses these contours. It chooses the next available higher contour. So after 20-meter contour, we needed a 25-meter contour for this purpose. The ECDIS does not have it on the CNC. So the next higher contour of 30-meter contour is chosen for this purpose as a deep water contour. Now we can see the area deeper than the deep water contour, which is more than 30 meters in here, is white in color, and the area between the deep contour and the safety contour is filled with gray color. So basically, this gray color filling the area between safety contour and deep contour is a filler color, and it does not have any significance of its own, except that it can represent a unsuitable area for operational requirements. Like in our case, this area is safe for navigation. There is no danger of any grounding. But since we are a chemical tanker intending to discharge our tank washings into the sea as per MARPOL requirements, we cannot be inside this area. So for that purpose, the vessel will have to stay out in this white area, which in this case is a clear area, for this operational requirement to discharge the tank washings. As long as she will be discharging this Annex 2 tank washings, she will have to stay in this white area. Once she completed her operations, she is welcome to enter the gray area, as the gray area is only unsuitable for operational requirement, which is MARPOL requirement, but it is safe for navigation. By this way, we don't need constant fixing of ship's position on ECDIS, as we clearly have a visual indication of a clear area, which is the white colored area on our ENC, We just need to keep the vessel in the white area all the time as long as we are complying with the MARPOL requirements. Once the tank cleaning is completed, vessel can enter the gray area. Now we can see that we have four colors: light blue, dark blue, gray and white. Dark blue is for shallow contour, and shallow contour works on a lesson principle. Light blue is for safety contour, and safety contour works on a lesson principle. And white is for the deep contour, and deep contour works on a more than principle. And gray color is just a filler color to fill the area in between the deep contour and safety contour when these two parameters have different values. Now let's have a look at what are 4 shades and 2 shades settings. So far we have seen 4 colors: dark blue, light blue, gray and white. These are the 4 shades of colors available on the ECDIS. Also we know that dark blue and light blue, which are shallower than the safety contour, are non-navigable waters because they are shallower, so they are dangerous, high chances of grounding. And the waters deeper than the safety contour are navigable waters. If any of us have any difficulty in classifying all the 4 colors, we can make use of this 4 shades or 2 shades option. This is a toggle button basically. You see now 4 shades is on. So when 4 shades option is on, all the 4 shades of colors are visible on the ECDIS. When I turn this 4 shades off, it becomes a 2 shades mode. I removed it. When I turn 4 shades off, it becomes 2 shades mode, which is basically only showing 2 colors on the ECDIS, which is dark blue and white, both representing non-navigable waters and navigable waters respectively, separated by the bold line, which is our safety contour. So if you want to navigate only in safe waters, you can make use of this 2 shades option if 4 shades can be confusing or if it's too much on the ends. So out of 4 parameters, we have already seen 3. All the 3 contours we have already seen: shallow contour, safety contour and deep contour. Before proceeding to the safety depths, we'll just see what we have learned so far. That there are 4 colors for representation purposes: dark blue, light blue, gray and white. Dark blue is for shallow contour and that works on a less than principle. Light blue is for safety contour and that works on the less than principle. White is for the deep contour and that works on the more than principle. So gray is only a filler color in between the deep contour and safety contour. We also learned that the safety contour, which is represented by the bold line, the only contour to have a bold line and the only parameter to generate an alarm, is the demarcation between safe waters and unsafe waters. So the gray and white are safe for navigation. Light blue and dark blue are unsafe for navigation. Now let's take a look at the 4th and final safety parameter, which is the safety depth. So far whatever we have seen, those are contours. Now what we are going to see, the only one is a safety depth. Many times the vessel would likely to cross safety contour, due to which the alarming margin diminishes. In these cases, safety depth is a reliable indicator to visibly mark safe waters from unsafe waters within the safety contour, but without any alarms. What happens here? We selected safety contour to 15 meters. Normally, as per formula, which we will see soon, the safety depth will assume the same value as the safety contour. When it's 15 meters, the safety depth is also 15 meters. So see, please see here, the 15-meter contour is not available in here. So the ECDIS chose the 20-meter contour as the safety contour, which is a bold line. Instead of 15, it is a 20-meter. For instance, I want to come from point A from here to point B, which is here. Technically, I'm not supposed to cross the safety contour, but this is where the safety depth comes into place, and which helps us to cross the area from point A to point B. Please set safety depth as the same value of safety contour, 15 meters. What happens now? The soundings, the charted depths on the ECDIS, which are deeper than the set value, which is 15 meter, will be gray in color. And all the soundings which are shallower than the 15 meters will be black in color. Please see the distinction, the difference between this depth, which is 14.6, and this depth, which is 16.4. This is black in color as it is shallower than 15 meters, and this is gray in color as it is deeper than your safety depth. So now this gives you an opportunity to cross the safety contour. Basically, why we cannot cross the safety contour is that is your last point of alerting system where it will generate an alarm. Now, as after you enter the safety contour, there are going to be no more alarms. But when you cross safety contour, you got to cross it on the gray depths, and which are your deeper than your safety depths. So from point A to point B, you just cross it on the 16.4 and 15.5 and come over to again deeper waters. This is how safety depths helps us, especially when crossing the safety contours, where it helps us to visibly see the safe waters from unsafe waters inside the safety contour, but without any alarm. This is its significance.
Now let's have a look at the safety parameter calculation and the associated formulae. The first one, shallow contour, is calculated by deepest static draft plus squat minus height of tide. Deepest static draft will be when the vessel is at stationary, what will be the maximum draft? That means when the vessel is at even keel, it can be the draft at either end, or when the vessel is trimmed, it is the draft, the maximum draft at the trimmed end. So that will be the deepest static draft plus squat, the anticipated squat for the ship's speed, also taking into account the room available, whether it is a open sea or confined waters. Based upon the speed, we'll have a look at the squat table and take this value. When we look at this deeper static draft and squat together, they are called as the dynamic draft. Or in other words, when the water depth is equal to the dynamic draft of a vessel, the ship's bottom touches the ground. That will be the first point of contact. We are subtracting the height of tide because in certain places like English ports, we have a tidal range of about 6 to 7 meters. So that means we have additional water under our keel that will prevent the vessel from grounding. So shallow contour, as we saw earlier, is a grounding contour designed to show the area where the ship would ground. So the formula for calculating the shallow contour will be the deeper static draft plus squat minus height of tide. The next one is the safety contour, calculated as follows: deeper static draft plus squat plus the UKC policy of the company or the CADS or correction, whichever is higher. There is a third entity in here, plus allowance for trim, list, heel or roll, because when the ship trims or lists, there will be an increase in the draft either way, plus dock water allowance and minus height of tide. We can see the common thing between shallow contour and safety contour. Shallow contour and safety contour, what do they have in common? The deeper static draft is there in both, the squat is there in both, and height of tide is subtracted in both. So, as we know, safety contour is the safety margin to prevent the grounding. So, we have this additional factors in this formula, making the safety contour deeper than the shallow contour. Also, from this formula, we can see that height of tide is the only factor that will be subtracted from both shallow contour and safety contour, whereas all the other elements are added. The next one is safety depth. The formula for the safety depth is the same as the safety contour. So whatever we calculate for safety contour, we can use the same one as safety depth. Let's revise the significance of the use of safety depth. Safety depths are quite useful when the own ship has to cross the safety contour. For instance, please have a look at this particular example where this is the 10-meter contour which is chosen as the shallow contour. For this particular voyage, the vessel has to choose 14 meters as the safety contour. But due to the unavailability of the 14-meter contour, the ECDIS chose the 20-meter contour as the safety contour. So basically, the area between 14-meter contour and 20-meter contour has become useless for us. Since we cannot cross the safety contour, we are missing that particular margin of depth. Whereas, when we have the safety depth equal to the safety contour, we set the safety depth also to 14 meters. So here, all the depths which are shallower than 14 meters are marked in black color, highlighted in black color, and all those depths which are deeper than 14 meters are shown in gray color. So this gives us an opportunity to cross the safety contour, but still we can navigate from the depths between 14 meters and 20 meters, which is shown by the gray depths. We'll have to stay on the gray depths and we should never enter the highlighted depths which are in black color. By this way, the safety depth has shown as a border for the 14-meter contour. The last one is the deep contour. The deep contour can be set as required. We saw one fine example of Marpol Annex 2 requirements. If there is no any such operation, we can set the deep contour to 2 times the draft of the vessel. That will be the depth at which the vessel would experience lesser squat. These formula, what we've seen so far, can vary from company to company. So please have a look at your company SMS before you start calculating the safety parameters for your own vessel. Also, whenever you get a value out of this calculation in decimals, for instance, when you calculate shallow contour, if it turns out to be 11.7, please always round it up to the higher number, which is 12. So far, what we have understood is, the more the safety margins, it translates to the navigation will be more safer. Let's have a look at this particular picture. This is the position of the ship. And this is the shallow contour. Otherwise, the point at which the ship would touch the bottom. But in the ECDIS, with the help of the ECDIS, the ship wouldn't ground with the safety margins available to us. Safety margin 1 and safety margin 2. Safety margin 1 in the form of the safety contour, and the other safety margin which we have is in the form of the safety frame, which is a speed variable factor. That means the length of this frame is going to change on its own. So it will prompt us by giving an alarm or alert us in due time when its edge touches the safety contour. Let's conclude this module by looking at a recap of what we have learned so far. This is a tabular column showing all the safety parameters: shallow contour, safety depth, and deep contour. Out of these four, three of them are contours and only one is a depth. So, for the sake of making it easy, I highlighted the safety depth in red color. The contour principle. These contours works on the certain principles. For instance, shallow contour works on a less than principle. Safety contour works on a less than principle, but deep contour works on a more than principle. That means when you choose a contour as a shallow contour, all the depths lesser than that particular number will be chosen as shallow area. And when you choose a particular contour as a safety contour, the area lesser than that and more than the shallow contour will be chosen as the safety margin area. And when you choose a contour as a deep contour, the area which is more than that contour, the waters which are deeper than this particular contour, is chosen as a deep area or safe area. The color scheme used for shallow contour is dark blue, safety contour will be light blue, deep contour will be white in color. And the safety depth is a very useful factor, we have seen it, and it uses two color schemes, which is gray and black. Gray is for the depths which are deeper than the safety depth, and black is for the depths which are shallower than the safety depth. The formula we have already seen. What is the hint in calculating and applying the formula? Before we apply the values in the ECDIS, let's make sure that the safety contour value cannot be less than the shallow contour, and the safety depth will have a value same as a safety contour, and deep contour cannot be less than the safety contour value. Alarm wise, we know that only safety contour will activate an alarm, as it is a safety margin, and it is also represented by a bold line feature, whereas I marked X in the other three parameters. That means they would not activate any alarm. What do these safety parameters represent? Shallow contour represents the grounding depth or dangerous areas. Safety contour represents the safety margin before grounding, and deep contour represents the safe waters for safe navigation. I hope all of you found this video useful. I wish you all a wonderful day. Thank you.